Hello and welcome to this series on IGCSE and GCSE maths. Today we're looking at a prism, a polygon, and we're looking at area, and then we're looking at volume. Okay. Hello, and here's our task, and I should try and paraphrase the whole thing. We've got a prism there, and it's got a length of 50 centimeters, and the cross section is a regular pentagon in the sense that AB is equal to BC is equal to CD is equal to DE is equal to EA equal to AB, and we'll discuss the length. The cross section over here is made up of it's in the shape of a pentagon, and of course we can see the cylinder, the original cross section of the cylinder from which the wood was removed to create the prism. Okay, now I've created a triangle OAB, and this is going to come in handy at some stage. Now the radius of the cylinder, original cylinder, was 15 centimeters, and I hope all that made sense. Now for the questions, we're supposed to find the angle AOB, which is this one here, and to find to calculate firstly the area of the triangle AOB, which we do later on, and next to find the area of the pentagon ABCDE. We can do that by finding the area of one triangle and then multiply by 5, and then the area of the and then calculate the volume of the wood removed. I mean, that should be easy as well, hopefully. And finally, the total surface area of the prism, and that's the difficult bit of the whole question. Now, to part A, we want to find the angle AOB. Now, because we can recreate 5 of these angles right through the cross section, because it's a regular pentagon, we can recreate 5 of these triangles. So, and the sum of the angles at the point is 360. So if we divide 360 by 5, we get 72, and that's the first question answer. So the answer is 72 degrees. Okay, now we're going to look at part B, and subsection 1 says find the area of triangle AOB, and subsection 2 the area of the pentagon, which is the area of the cross section, got the cross sectional area. And part C, the volume of the wood removed, the volume of wood removed from the cylinder. Right, now for subsection 1, the area of the triangle OAB, if we use the formula half BC sine A, in this case B and C are equal. Okay, so you do a half times 15 times 15 times sine 72, that gives us about 107.0 degrees centimeter squared. Now, because this is a regular pentagon, we can recreate 5 of these triangles right around right within the pentagon itself. So to find the area of the pentagon itself, ABCDE, we multiply the area of triangle AOB 5 times, and that will give us a figure of nearly 535.0 centimeters squared. Okay, now moving on. We want to find the volume of wood removed from the cylinder. Now, firstly, we need to find the volume of this prism, and then the volume of the cylinder itself, and then subtract the volume of the prism from the volume of the cylinder. So if we do, the volume of the prism will be the cross-sectional area times 50, and that will give us 36,748.25 centimeter cubed. And the volume of the cylinder itself will be pi r squared times the depth, because pi r squared is the area of the cross section of the cylinder itself. So if we do pi r squared, which is pi times 15 times 15 times 50, that will give us the area, that will give us the volume of the cylinder. Now, if now subtract the volume of the prism from the volume of the cylinder, that will give us the area of wood removed to let us create our prism. And the answer is 8,000 594.67 centimeter cubed. Hope that makes sense. Okay, now for part C, we're supposed to find the surface area of the prism. Now we can't find the surface area of the prism because we don't know the value of B or C, D or E or AB, and because they're all equal, luckily we know we've got a triangle OAB in which we know all the angles and we know two sides. So to find AB, we have to use the sine rule. So AB over sine 72 is equal to either OA or OB is equal to OA over sine 54, and that's the sine rule. And from that we get that AB is equal to sine 72 times 15, when you cross multiply, that is, over sine 54. Now that gives us an AB of 17.63 centimeters. We now know BC, and if we find the area of if we find the area of this rectangle here and then multiply by 5, because there are 5 rectangles in this prism. Okay, so now if we do 50 times 17.63, that will give us the value of 881.6807 centimeter squared, and that's the area of one rectangle. But there are 5 of these, so if we do that times 5, we get an area of 4,408.39 centimeter squared. Now we need to add the area of the two ends of the prism, and that will be the area of the cross-sectional area of the prism itself. And previously we had the figure of 535. Now if we double that, we get 1070 centimeter squared, and when we add both, we get the figure of 5,478.4 centimeter squared. And I hope all that makes sense. Please subscribe, and it'd be nice to hear from you and to tell us what you think of the video. Meanwhile, I wish you the best and see you soon. Bye bye now. Bye bye.